Welcome again to Basecamp 7. This is the fourth session of this cohort out of a total of 6. And today we're going to be talking about testing smart contracts. And I'm going to be working with Robert today. So we're going to some a little theory about testing, and then we jump into some light coding using the Starknet Foundry. And Robert's going to show you how to use it. So just to recap, session 1 was about fundamentals on Starknet, on Cairo. Then session 2, we solved Starklinks live just to understand more about the Cairo syntax. Then session 3 was more of a deep dive with Starknet, with Pierre shows how to create a smart contract from scratch using Scarp, using the Starklight, using Katana for local development. And today is going to be all about testing. Session 5 is going to be architecture, and session 6 is going to be front-end. Okay, topics for this session in particular. So we're going to talk about testing in Web 3 and how is it different from testing in Web 2. I usually make comparisons to Web 2 because that's where I'm coming from, even before I joined the Starknet ecosystem. I'm going to talk about a little bit about upgradables, a smart contract, and how, the do's and don'ts. Then we're going to jump into types of tests you can perform in the smart contract. Then discussion about local devnets. We saw one of them last week with Pierre, Katana, but there's another one. Finally, a brief introduction to Starknet Foundry, the tool we're going to be using today. We're going to have a short break. Hopefully we can have the 10 minutes today. And then we're going to jump into the live coding session. As usual, this recording is going to be shared with you via email, and then also uploaded to the playlist on the Starknet Foundation YouTube channel. So let's talk about Web3 testing, right? So the first notion that I had to learn is that the mantra in Web 2 of move fast and break things, that doesn't apply to Web 3. It's actually the opposite. You have to test your smart contract as if you were in NASA, right? Like in NASA, when they put software in some spacecraft that's going to be, millions of miles away, they have to make sure that there are no errors, because you cannot do, an upgrade. Maybe they'll do small ones, but nothing significant for such a long distance. So like in NASA or like in space exploration, when you test for a smart contract, you have to be mindful that there's no room for error. And that is because in Web3, it's a highly adversarial environment. So you have many actors trying to find bugs and vulnerabilities to your smart contracts, try to exploit it. So even a small bug in your smart contract can be catastrophic, right? Can be the end of your project, can be complete drain of funds. So the stakes are even higher than on Web 2. So an approach for that is to have what's called like defensive coding, do very rigorous testing. We're going to talk about the different type of testing you can perform. And then at the end, to also do code auditing when you're ready to go to mainnet. I mentioned that, once you deploy it, a smart contract cannot be fixed. Well, that's not always true, because you can make a smart contract upgradable, but that comes with some caveats that we need to discuss. So the caveats, and this is my perspective, is that an upgradable smart contract is okay on testnet. You're just trying to, give it a try, invite your first users to see how it goes. But it's not okay on mainnet. And you don't want to have a upgradable smart contract on mainnet unless, so there are certain conditions that actually will be okay for a smart contract to be upgradable on mainnet. One of them is that if your smart contract is written in Cairo 0, you actually need it to be upgradable, because there is a thing coming that's called regenesis, that basically Cairo 0 code is going to be disabled, and you're not going to be able to execute it anymore. So if you want to upgrade to Cairo 1, you need to make sure that your smart contract is upgradable. I don't think it's the case for any of you here in Basecamp. If you're in Basecamp, you're learning Cairo 1, like the latest syntax. So this doesn't apply to you, but for some people who were in the ecosystem before, it actually applies to them. Another exception, or when you can actually make a smart contract upgradable, is when the upgrade is actually triggered and controlled by the user. And this is very a specific use case of account abstraction, like your wallet. when you go to Bravos or you go to Argent X, sometimes you have to upgrade your user account. And that is fine because you as a user are the only one able to trigger and the only one affected by upgrading the smart contract, in this case, the user account. So that's fine, that's good. Then it will be okay when you're talking about a protocol, like a smart contract used by many people, if you have some kind of decentralized governance to control the upgrade. And this is something that has been done a lot on Ethereum. For example, Uniswap is the example that comes to mind very frequently, how they handle upgrades. And the result of certain voting as part of governance is actually what triggers the upgrade. And the code for the upgrade is also defined upfront. But then that upgrade cannot happen immediately after the voting ends. It's actually, you need to implement some delay or a time lock to allow for people who don't agree with the upgrade to actually leave the protocol or to fork it and create their own version. So on top of that, you need to make sure that your protocol is easy to fork if the decision is controversial to upgrade the smart contract. So people who don't agree with that can actually continue with the old version of your app, right? So under those conditions, upgradable smart contracts are okay. Any other situation, for me, it's a code smell. Like, you shouldn't do it. I don't know, Robert, you have a different vision, or Pierre, about this.
No, I mean, it's important to know it's possible, but definitely must be take care depending on the use case. So that's a good point.
Okay, thank you. Let's continue. So what type of test can you perform with a smart contract? You can break it down into three big categories. You have the unit test, you have the integration test, and you have the end-to-end tests. So a unit test is when you test a specific function, either a public or a private function, just on itself, right? Nothing else. So for that to happen, you have to mock every dependency. So you're making sure you only test one function at a time. Then you have the integration test, or we usually call it the smart contract test, where you test the logic of a smart contract just by using the public interface of the smart contract and not making any assumption about the internals of how it works. So normally the way that you will do it, for example, in the Starknet Foundry, is by simulating transactions. So you're going to see how you can use cheat codes for the purpose. And in the background, what's happening is that the tool emulates a sequencer. So you emulate the Starknet running in your computer, so you can test the public interface of smart contract as a user would, or as another smart contract would, using transactions. And finally, you can perform end-to-end tests if you're building a full app. That also includes a front end. So in that case, you perform the test from the app, from the UI, and basically you try to mimic the user behavior, doing some automation. That could be like Cypress or Puppeteer. Now the testing pyramid. So in any code base, usually the biggest amount of tests that you can find on a code base is going to be unit tests, right? So that's where you start your test. That's the most commonly used type of tests. So here you test only individual functions, and you can use basically two test runners. You can use the test runner that comes with Cairo itself. Let's call it a Cairo test. And you can also use a Starknet Foundry for that purpose. Then you go to the integration tests or the smart contract test, where you test using the public interface only. And again, you can use the default test runner, or you can also use a Starknet Foundry, which for me is like the better option because cheat codes, basically. And finally, when you come to the end-to-end test, these are you're going to find fewer of those in your code base because they're take more time to implement, to maintain especially. And then you will use tools like Cypress or Appium or Puppeteer. So the division is that whenever you're in the unit test realm, you treat your code as a white box, so you know exactly what's going on in the internals. But then when you move up in the integration and end-to-end test in the pyramid, now you think about your code base as a black box, right? You don't make any assumption on how it works internally. You only care about the public interface. Of course, you usually have more unit tests than anything else is because of the performance, right? Unit tests are very fast to execute. And then as you move up the pyramid, the tests are usually slower to execute. But then the opposite is true, right? The closer you are to the user behavior, the more valuable that test is going to be. So you have to find the balance that actually works for you. Now, there are more type of tests that you can implement on a smart contract, right? You can do, for example, manual tests. This is what QAs, the quality assurance, usually do, right? That you deploy your app to a testnet, and they actually try to break it by just interfacing with the UI of your app. You can perform Fuzz tests, which basically, instead of just giving a particular input to a function, you can provide a broad range of inputs. And basically, it's a way to verify that your code is actually able to handle very unexpected values. For example, very large integers or negative values or zero. You know, all the edge cases that are sometimes hard to think upfront in a regular unit test or integration test. Then you can do fork tests that basically tries to create a copy of a partial copy of the state of Starknet, so you don't have to mock dependencies. You can actually use real state from other smart contracts. I don't think that's possible right now with Foundry, if I'm not mistaken, Robert. Right? I think it's only, I don't think fork test is supported right now.
So currently there is support for fork test, and we'll quickly cover that. Today actually they updated to the new version, and there's some interesting things there.
Oh, cool. Nice. Okay. And finally, other, let's say, tools or processes that might not be directly testing, but they are associated with that is static analysis. So there are some tools that you can actually go through your code base and give you some hints and suggestions. And then there's another area that's called formula verification that we're not going to cover today, but something interesting to keep your eye on. So last time we saw a local devnet, right, with Pierre. We use Katana. And this is also very useful for testing, because the idea is that you're able to run an instance of a Starknet in your laptop, right? So the idea that in your laptop, you're going to have this devnet. And this devnet is going to expose a JSON RPC, just in the same way that the sequencer actually exposes an RPC or a full node. And it's usually in localhost, this particular port, 5050. And that JSON RPC is what, for example, a CLI, an SDK, or your app is going to use to interact with the devnet. You can even use the Stark scan if you put the subdomain devnet. So you can use the block explorer to interact with your devnet running on your computer. So they all interact with the devnet through the JSON RPC. And then there's going to be a sequencer in the devnet that's going to handle the transactions and perform the state management. Then these devnets, they have usually predefined user accounts that you can use, because they also preceded with some test ETH for your tests. And they also come pre-deployed with a universal deployer that we saw, I think, in session 1, how it's being used to deploy your smart contract. And that's where you eventually deploy your own smart contract to perform different types of tests. So this is the local devnet. And there are two main local devnets, right? We have Katana that we saw last time, and there's also the Starknet devnet, right? Two different projects. Katana, of course, is built with Rust. The Starknet devnet started built with Python, and now they're doing a rewrite to use Rust. I don't think it's out yet, the Rust version, but the Python version for sure it is. They also use different sequencers that they follow the same logic, but they say two different clients. Katana uses Blockifier, and Starknet devnet uses a Starknet in Rust. They both use the same version of the RPC protocol, version 4.0, the same as the real sequencer. So the same endpoints that you have in sequencer, you will have it in the local devnet. In the case of Katana, was developed and maintained by the Dojo engine. There's a consortium of builders in the community. So it was built focused on on-chain gaming, but you can use it for any other purpose, right? As long as they follow the same RPC versions, you can use it for anything. The Starknet devnet is actually developed and maintained by SpaceShard. And here you're going to have the link for both of them. So finally, the tool that we're going to use today is called the Starknet Foundry, MS here and R. So if you're coming from Ethereum, you're probably familiar with Foundry. It's an awesome tool for testing. On Starknet, we used to have a tool called Protostar. which also you had cheat codes. It was built in Python. So the same team that was building Protostar is now the one building Starknet Foundry. So this team is so far mentioned. And with Foundry, you can do unit tests, you can do integration tests. Apparently, you can do fork testing, and in the future, probably you can do even more, probably even Fuzz testing. I don't know. I'm not so much up to date, so maybe Robert can answer those questions. But the big thing about this tool is that you can test using cheat codes, right? A way to modify how the sequencer works, so the internal state, just to allow you to do more interesting type of tests. So if you come from Foundry on Ethereum, it's the same way to test. It's built with Rust, so it's very fast to execute all your test suite. And it comes with two main binaries. You have Forge, which is the test runner, and then you have Cast, which is a CLI for Starknet. And they also have a whole book that you can use to go through and learn how to use it. And just to summarize, this ends the theory part of the class. So test thoroughly before you deploy. Remember, test more like NASA. It's a very adversarial environment. Think twice before you make their smart contract upgradable. It's okay under certain circumstances, but not always. And the most commonly used type of tests are unit tests and integration tests. More advanced one could be Fuzz testing, fork, and end-to-end tests. You have two local devnets, Katana and Starknet Devnet. And with the Starknet Foundry, you can test using cheat codes. And finally, there's two binaries, Forge and Cast. That's all. Actually, I think we can continue. It took less time than I expected, only 20 minutes. So we can just continue with the live coding and then have a break at some point in the live coding. So let me stop here to see if there's any questions for you guys before I hand it over to Robert. And there's some questions. Let's see. Nothing in the Q&A.
There's actually a question regarding Cast. So the question is Cast a good alternative for Starkly or Starkly, or do we have to use Forge with Starkly for best results? That's a good question. I honestly use them both depending on the use cases. SN Cast is usually a good option for Starkly, but for now I use them both in that sense. I think Starkly has more features implemented compared to SN Cast, but once SN Cast has more features implemented, maybe you can switch there. I don't know. Cool. Okay, so then I'll continue sharing my screen then. Give me just 1 second. Let's see if everybody can see my screen. So, questions. Is it big enough? The font, the size?
No, can you make it bigger, please?
A bit more if you want, but that's fine.
This, okay. A little bit bigger, and then I have to step back a couple of. I'm kidding. So, first things first. So, before we start getting into the live coding, we need to make sure we have the proper tools installed. Before setting up Starknet Foundry, we basically continue from the last session, which Pierre was hosting. And it was building an ownable contract. In that session, we saw how we can build an ownable contract, but we also installed tools such as Scarb and Katana. I assume that you already have those tools installed. If not, I'll just grab the links here, and then I mean, you can go to the Scarb documentation and then to the Katana documentation. Make sure you have Dojo and Scarb installed before this, but I believe everything should be installed prior to this. Next is Starknet Foundry to be installed, so I'll pass the link to that here in the chat. The installation is very simple. It's just a curl command that you copy and insert it into your terminal. So you do this, you install it, and just wait a couple of seconds depending on your internet, and everything should be installed. To check if the installation has been successfully installed, run the following command: SN forge version and then you should have the 0.7.0 version. I forgot to ask, is the font for the terminal good? Readable? Okay.
Yes.
Okay, cool. So yes, now we successfully managed to install Starknet Foundry. And what we can do now is basically start creating our project. So to do this, I'm just going to create a directory called Basecamp, and then I'm just going to cd into it. Now with Starknet Foundry, we're going to see two ways how we can build a project. One is basically from initializing from Starknet Forge. And second, I'll clone the repo from Pierre from the last session, and we're going to adjust that project for Starknet Foundry. So to show the both cases, you can first do SN Forge init, and then the project name that you want to be called. So in this case, let's say Foundry template. Okay. And then we can see into this. We're gonna just quickly look at it, take a glance, see what's there, and then we'll start building it from scratch with the previous with the ownable project. So let me just increase the fonts here. Hopefully that's good enough. So we have the source file, we have the test source folder, we have the test folder, and the Scarp tunnel. In the source folder, we have a simple contract as a template. It's basically has a storage where we store the balance, and then we have the, just give me 1 second to do this. Okay. And then we have the public functions defined here in the external attribute. And these are increase balance and get balance. In this case, from the last session, we learned that get balance is a read function because we only pass the contract state as a snapshot. So this is just a snapshot of the contract state, which is immutable. And then increase balance is a read-write function where you pass a reference of the contract state, and then you perform certain functionalities there. Then we have the interface defined at the top, which follows the functions that we defined. That's basically it. Now in the test folder, there's some examples for test. However, I won't get into too much detail of it because we're gonna build them from scratch. But there are, I think, 3 tests or 2 tests that test your contract. Lastly, there are some added configurations to the Scarp tunnel in where you can see that the Starknet Forge repo has been added. So this is the library where you add the dependency on it. And in addition, we set the chasm code gen to true. That's basically about it. So far, any questions? Everybody following? So this repo, yeah. So this repo, you don't have a link. You basically initialize it. So this is the command you initialize. So SN Forge -- init, and then you have a certain name for it. That's basically it. And you can start your project from this from scratch or from this template. Okay. I'll just exit this now. I'll go a little bit back, and now I'll go back to Pierre's repo. I'll pass this here, so everybody has access to it. And now I'm just gonna clone this repo into my machine. So git clone, and I'm calling it, let's say, ownable. cd ownable. Here. Now I think here we have so we have the demo project, which will be the one that we're looking for, and then we have the Starknet Katana, where we have the configuration for our Starknet account on Katana. We'll discuss about that in a bit. once we reach the phase where we deploy our contract on Katana with Starknet Cast, SN Cast. So let me go into the demo here, and then here I'm just gonna open my VS Code. Okay, so now just to kind of like quickly recap what's happening here. We have our ownable contract where we have defined our storage, where we store our owner and the data variables. Then we have an event, and then we have defined for that event the certain parameters that we want to track. We have the constructor, where in the constructor we have initial owner that is required as a call data. And then based on that, we're gonna append this to our storage. And then we have our external functions defined that are other function, get data, set data, and then this is based on the iData interface. And then another external function, which is based on the ownable trait. And then here we have the transfer ownership and then owner. In this case, owner is, again, a read function because we have the snapshot. And then transfer ownership is a read-write function because we pass a reference to the contract state. And then this is a generate trait. Okay, cool. So now that we have the recap of the ownable, oh, and I forgot to say that we have the two interfaces defined in the beginning, and these implement the functions that we defined. Great. Now that we have recapped the ownable contract, I would like to start first to introduce you how to, like the old way to test contracts. So we'll start building a unit test. And then after that, and then this unit test will run Cairo test. So we'll see that example as well. And then once we build the unit test, we'll do an integration test and we'll switch to Foundry to see the actual power of Foundry using cheat codes and other helper functions. Okay. So to do that, again, unit tests are tests that are focusing on a specific function. And these are usually found within each Cairo file. So for example, if I want to test the where is the constructor to if the constructor work properly, I'm just gonna use I'm just gonna build the unit test here. So I'll start by creating a mod, and then I'll call this unit test. In my case, I'll call it the unit test so it's obvious, but you should also, whenever you work on big projects, you should have a good naming for it so you know where everything is. And then here, I'll just I'll call this apologize test, and then Fuzz unit test. That's the naming that I want. There's a question or a hand, something, or no? Okay.
I think it was one mistake because I don't see any hand raised right now.
Okay. So, couple of things. Before you start writing a test, each test function has to have the attribute test. This is what you need to have to have it defined. The next important thing is to have an available gas defined, which basically tells to the compiler how much gas is available for this test. And just to see if this is properly working, I'm just going to create a simple assert function, which I'll test for 1 equals 1, if not equal. Equal, if I can spell it properly. Okay, and then I'm just going to quickly come back to my terminal. And here, what you can do to see if this actually works is run spark test. Or actually, I think I should build first. Or no, it works without building. Okay, so you can see here that the test has been successfully run. And then you have here test, demo, test, unit test, and then it says okay, and then you also have the gas usage, which is pretty nice. Now let's change this and to actually test the constructor if it worked properly. To do this, as I mentioned, I'll go back to the constructor to see what we need as the initial input. So we'll need a contract address, which will be the initial owner. And to do that, I'll just create an address called admin address, and then a contract address. And then this will be, let's say, admin. And then to turn this into a contract address, I'll do try into, and then try into usually as a result as an option, and I have to unwrap that. Now I have a issue that I'm not using the contract address to import that. I need to import from Starknet, and then contract. Contract. Yes. I see that my tabs are not really properly. Contract address. My tabs are not properly working, so I'm note to myself: don't use autocomplete. Sometimes it doesn't work properly. So that's it. So I created my. Let me just hide this for now. I created my admin address. And now what I need to do is basically, I need to, there's a function called deploy syscall, which basically deploys the contract itself. And the deploy syscall takes several parameters. And you can check the Cairo repo. And this deploy syscalls as parameters takes the class hash. Takes contract address stalled, the call data, which will be our constructor data, and deploy from 0, which basically means that if it should deploy it from the 0 address. So to do this,
Robert, can I ask you a question? And I know
yes.
Pierre actually answered the question itself, but just so it's in the video, how come you're using a string, a short string for what's usually is an address like 0x1234?
Correct. So I'm using a short string because it's more readable whenever you're testing. So you can create also from like a constant address. But this short string actually tells me more about the address that I'm creating. So it's very handy to create these type of addresses. And we'll see that when we create the integration test, we're gonna go even further with this and create them as constants, and then use these across our integration test. So that's very, so for me, like whenever I try to see like, okay, what type of address I'm using, I see admin, right? I can create another address called bad guy or whatever address that I want to. So it's very useful whenever you're testing.
Thank you.
Thank you. Okay, so as I mentioned, we need to call the deploy syscall. But for the to call the deploy syscall, we need to construct our call data. And to construct our call data, so the call data is usually an array of fields. Where is it? You see, like it's a span of fields. And then to do this, first we'll create an array, and then we're gonna span that in the function. So we're gonna say let mutable, let mute call data. And then here, there's several ways to create an array. The old way is with append, but the new way is basically you call array, exclamation mark, and then here you'll put the admin address that we have. Now, as I mentioned, it has to be a felt. So to do a felt, you have to use the int method, which basically converts it to it's typecasting, and it puts it into a felt to 50. Let me see. I think we need to import these as well. So that's basically use array, and then for that, I think let's say array trait. And then span trait, we will use it just in a bit. and then we'll need to the into method into and try into as well, and then the option trait as well. Okay, there's a question.
Yeah, sorry. I think this is for the new backend they releases, because normally now everything you just enter is in the prelude. So normally you shouldn't have to import them, but I think it's, you know, the release they made, perhaps they are missing some stuff from the check, you know, of the backend server. Because normally you are it's carb 0.70, right?
Yes.
Yeah, so you should normally have everything of this inside the yes, you should have normally everything of this in the prelude, so you not normally have to import all of them, but I think it's more about the language server, I think.
I see. Okay. Yeah. Thank you for that. I'll try that. I'll import them now so the language server behaves properly, but we'll also test it to see if. But that's good feedback. Thank you. I do know that. So yeah, just I think I need to also import this result and then result trait to successfully. Okay, should be fine. We'll see if it miss anything else.
Question from there. How can we see what it's included in the prelude? Is there a place we can see what comes included?
Unfortunately, I think it's just the compiler code. I will check it, but I think there is no documentation for that, and that's a good point that we should check for the Caro book. That's a very good point.
Okay. Yeah. Okay. Now let's move further. And now that we have our call data, what we need to do else is basically call the deploy syscall. And for that, we first have to import it. So I'll just use that. So use Starknet and then syscalls, and then maybe also probably this is also already, you don't have to import it, but yes, we'll just import it for the sake of it. And then now what we can do is basically and then we're gonna have two parameters that we receive back from here, and I'll address them in a second. Deploy syscall, and then what we need to do here is basically call the ownable contract that we have on top. And then to do that, obviously I have first to import it. Use, and then how to import it, you can use, as Pierre mentioned previously, you can use super and then ownable, but this is basically not that recommended because your project might change across, so you can use the name of the project itself. And then here we have ownable, and then here what we have to do is get the test class hash. And we'll have to put it into we'll have to cast it with try into, and then this again we'll have to unwrap it. And if we go back, now we have to pass the contract address salt, the call data, and deploy from 0, which is a boolean. So to do that, salt is for now is 0. Call data, it will be our call data that we created, and then we have to use the span. And finally, we'll say don't false. And then this one also will, if you you're gonna receive a syscall, which is an option, and then you have to unwrap it to get the values. And what we'll receive from here, if we check, we're gonna get the contract address of the contract, and then the return value of the constructor function. So for now, we don't have any value for the constructor function, and we only need the address. So we're gonna say address 0 or contract address, depending on how you want to name it. Okay, now that we have successfully deployed it, you can also test it out to see if, you can run scar build and see if this successfully builds. It says like I have an issue here. That address identifier not found. Oh, I forgot to I have this array.
Let me check.
Try into so deploy syscall, call data span. Yeah, this is live coding.
Yeah, no, actually, we need to figure it out. Can you show the error again?
Yeah, it's identifier not found.
Can you try to put the module, the top level of your module of testing in the configuration test, just
Yeah,
to see if it supports some additional stuff?
So the configuration test, I really want to cover this
Oh,
analysis.
sorry. No,
Yeah,
but
the
it might be related to that because it's a module and it depends on it, so it might be related.
I see. Could be. So the thing is, it's actually a good point to address this. So the configuration test. So what this implies is whenever you're adding this to your module test, it basically says to Spark or to the compiler that, hey, don't use this whenever you're building or you're compiling the project. Why is this useful? Is that because it's way faster to compile your project like this, and you just want to run it whenever you just use Scarp test, for example, or Cairo test. And yeah, let's actually, let's Scarp test. I mean, I can test it like this and see if this works. It's successfully deployed. Running. So there's an issue. I'll just address it in a second. Let me just okay. I'll address this in a second. So last but not least, this is the deploy syscall that where you deploy the contract and then you receive the address of the contract. And then what you need to do is basically import dispatchers from that your interface generates. So at the top of your function, whenever you have these interfaces, the compiler will automatically generate a dispatcher and a dispatcher trait, and we'll use those to actually interact with the functions defined. So to call those, we'll say, actually, let me put this here, use demo, and then I think we have, we'll work with the ownable trait, and we'll see if the owner has been actually set to what we want. So ownable trait, and then we have dispatcher, and then ownable trait, and then what we have is ownable trait, dispatcher trait. That's what we want to use. And now what you can do is we can call we can set our contract. So let mutable contract, and then we can also follow the same notation of address 0 contract 0. And if you have multiple contracts deployed, you can just address 1, contract 1, and so forth. And then we call the dispatcher, and then inside the dispatcher, we need to pass the contract address that we have. So contract address, and then here address 0. Exactly. And then finally, what we can do from here is to check if we manage to set the owner of that contract. So we're going to do a search. We're going to check this, and then we have our first contract that is defined initially, and then we're going to check this against the contract that we have deployed, and then we're going to call contract 0, and then from here we have access to the functions inside that interface, and if this assertion is invalid, then we're going to say not the owner. That's basically what we want to do. Okay, let me quickly glance through it to see if I have correctly defined all of this. Deploy syscall, so we have ownable, test/try into unwrap. Correct. And then we have the salt. We span this, and then we say false. And then finally we unwrap it. The imports are correct. So we have the contract itself, and then we have the dispatcher. And the dispatcher trade, we have what we need: the contract address, the into, the try into, and then the option trade. The array and the span result, I should be fine, I think. Let's see. So we'll try again to run scarp test. Unwrapped failed. Gas usage. Panic. So the unwrapping failed. Okay, so we have some issues here on the deploying of the function, which I am not entirely sure why. Address. Anyway,
What you can do to have a more explanation is, instead of unwrap, if you make a match, the error should be more, it should give you the reason exactly why the deploy cannot be done. So we can try it if you, because it might be related to the initialization or stuff like this. Yes.
Oh, let me try this again. Yeah. Oh, anyway, I think we had an issue here. I don't know exactly. Maybe let me just check the configuration files. Should be fine. Not entirely sure. Yeah, I'll have to debug this then a bit later. Okay. Okay, that this is. Let me just. I don't think even the gas is the problem, or I'm not even sure if the gas is the problem. Oh, the gas was the problem actually. So actually, the problem was the gas. I think I had 10,000 gas. So I wasn't paying attention. So good point. So the available gas is basically what you define. It's like whenever you don't allocate enough gas to your test function, it's obviously going to fail. And whenever you run scarp test, it's going to say something that didn't pass successfully. So I'm just going to allocate enough gas. I think the maximum, correct me if I'm wrong, the maximum gas limit is on testnet and mainnet is 3 million steps, which is basically 3 million times 100, because each step is 100 gas or something like that.
Sounds right.
Yeah, so that's one thing that we have to take care of. So yeah, apologize for not running this from the first try, but this is how we implement the unit test. This is the old way to kind of like implement and deploy your own contract with the deploy syscall. But now with Starknet Foundry, we will see a simpler method how to implement this, and we'll see how to use the cheat codes as well. Now, any questions so far? Otherwise, I'll go adjust the project to a Foundry style. So let me know if there's any questions so far.
Looks good.
Okay, cool. Okay, then let's try to. How did you make the admin address into red line go away? You have to import the where is it? The try into. So make sure to have the try into imported. But as Pierre said, with Scarp 0.7, this already should be available with Scarp. Only that the language server will just comply about it.
Robert, it's 11:55. We're almost halfway there. So when we have a 5-minute break right now before we jump into Foundry? It's like a perfect way to stop for a moment.
Yeah, perfect. That sounds good.
All right, so 5-minute break. Get your coffee, get ready. So we go back to Foundry later.
Sounds good. See you in 5 minutes. Definitely, yeah. So hopefully everybody is back with a cup of coffee or tea or water. And now we're ready to switch to Foundry. So what we've seen so far is how to use the Cairo test. This is how you can build a simple test. However, now we're going to switch to Foundry, Starknet Foundry, and we'll see how we can implement powerful features such as cheat codes. So to start, first you have to adjust the project a little bit. To start this, basically, we go into the scarp tunnel configuration. And here we have to import the dependency, which is SN Starknet Forge. Just give me 1 second to access this really quickly. I mean, you can go to their here, I believe, and then they should, project configuration, I think it's the one. But I do have it in my hand. It's this one. So you have to pass SN Forge there. If you want to follow, I'll actually send the exercise itself so you can have access to everything that we're doing, and you can follow step by step. And then from there, you can take all the necessary links or dependencies that we have. So we need to import this. I'll just quickly hide that. And then last but not least, we have to enable Chasm. Okay, once that's done, what you still need to do is basically create a test folder, because as I mentioned, unit tests are found within each Cairo file. So this is where we have our unit test. And if you have multiple Cairo files and you want to perform unit tests, those should be there as well, like in those respective files. But for integration tests, we go ahead and create a new folder called test. And then inside this folder, we're gonna we're gonna create our first integration test called test on level. Let's say like that. Okay. So far, so good. Now, there are a couple of things that we need to set up. So I think 1 hour, maybe it's not enough. So I'll try to speed up a bit in terms of what we import and what we use. First of all, to create the test, it's the same process. You have the test attribute defined at the top, and then here you have FN. And then let's try to perform the same test where we test the constructor with, for example, admin, right? So we try to test the constructor again with the admin itself. Now, before I go ahead and write the code logic there, I'll first create my helper function, which is basically my deploy contract function. And then that's a basic a private function that's within your test file. And we're going to call it deploy contract. And then here we'll have to pass as parameter the name of the contract itself. The name of the contract in our case is ownable. So that's what the name will be here. And then what we receive back is basically the contract address. We'll have to import a couple of things. So first, we'll have to import from Foundry. You have powerful features such as the declare function. So to import that, we'll say here at the top, SN Forge, STD, and then from here, I'm gonna import declare and declare, and then what we have is contract class straight. And I think I need to also import the contract address. Use Starknet, and then here. Okay. Great. Now let's try to build the same thing that we did before. So we have the let contract. be equal to declare, and then this is the name of the contract that is going to be declared. And then once we have that, we'll try to we have to deploy the constructor data, or the call data in our case. And then once that has been defined, then you will be able to deploy the contract, right? That's our target. And to do that, contract deploy, and then for here we'll have to pass the constructor data, or the call data, and then this has to be unwrapped again. Okay. And actually, I won't use. I'll remove the semicolons because this will automatically return the contract address. And if I put the semicolon, I just need to define like contract address and then return that. Now, if you want, there's actually two ways to build your constructor data or call data, and that's one way we've seen here as we defined. Where is it? So we defined an array, and then from that we pass this call data in that with that array. But now one of the powerful features of Starknet Forge is actually you can also read from a text file. So I'll use this for now, and then we'll also read from a text file as well. So let mutable call data, or in this case, let's call it constructor data. Or call data, it's fine. Okay, that should be fine. And then call data here as well. Great. Now what we need to do is basically declare the admin address. And to do that, one of the interesting features is what we can do is create a mod here. And then we can call it account. And then inside this mod, we can create our functions that will return the contract address. And this is not necessarily like, this is our like a very nice feature on top of your testing case. So this is what I'm gonna do, try into, and then I'm gonna unwrap this, the same thing that we did before, like here in this case, right? And then I'll remove these because I don't want to, I want to return it as a contract address. Last but not least, because we use a mod, I have to import this so it has access to this libraries, Starknet, and then contract address. And here I can create multiple, like I can create another one and say bad guy or bad address, bad guy, whatever. And we'll see how we're gonna use across our testing these two functions, and it's gonna look very nice. Okay, what we can do here, I can call this. So we have the array, and what we can do here is basically, actually I have to define the let account. I'm gonna say the account, and then contract address, and then here account. And then we're gonna say this function. And then this is gonna create my admin account. And then I'm gonna pass this admin account into the array. And then I can do into, because I have to pass a felt. The array, the span will be a felt. Okay, now let's try to actually deploy it and to see if actually like we managed to create we successfully deploy the contract. So to do that, I can do something like this. Let contract address, and then deploy contract. And then here I said that you have to use the same name that you have defined in your contract, ownable. And then usually whenever you have a test, you always need to have an assertion function. Otherwise, it's going to fail. So in Foundry, it is expected to have an assertion function. But to do that, we're going to say not equal for the sake of it. Okay, let's see if I imported everything that we need. I think we need the array. Use array. Actually, I'm just going to grab all of these goodies here. And I'll just remove the syscall. Should be fine for now. Auction trade into option should be fine now. Okay. Looks good. Now that we have that built, let's try to run SN Forge and see if this actually compiles. Obviously, we're gonna have an error from the first bat. So let's see, contract address is defined multiple times, which makes sense because I already have it defined here. Let's run it again. And so with SN Forge, whenever you run it, it always compiles the project and then performs this task, right? So we see that we have a failure, and then this is our unit test that we created, and I'll address that one in a second. And then we have the test ownable, and it seems that it had passed, the assertion works, and that means that whenever we try to deploy our contract, it also deployed successfully. So why this unit test fails is because Starknet Foundry uses their own function to declare and deploy, and because we're using the deploy syscall, it will fail. So for now, it's either we can ignore it, or you can change it accordingly to implement the deploy contract and to use this function to deploy the contract, and then to call the owner function there and do the assertion. I'll just comment this for the sake of it, so we don't have any failed errors. And now what I try to do is before building the test constructor with admin, I want to show you also how to read from a text file where you have the admin account as well there. So to do that, you have to import two things, and that's from SN Forge, STD, and then here you have, I think it's now they changed with the 0.7.0 to IO, and now you have file trait and read text. And to quickly kind of like cover read text and all of the cheat codes, and then we'll see how those works. So we have the cheat code references, and these are very powerful features that allows you to, so the cheat code manipulates the blockifier state and allows you to do certain things. So for example, the start prank basically allows you to change the caller address for for the contract that you're passing. Stop prank cancels that start prank. The start roll basically changes the block number for a contract. The start warp changes the block timestamp for a contract. Get class hash, you retrieve the class hash of a contract. Mock call is basically mocks a function within that contract. And L1 handler executes a mock message arriving from Ethereum. And lastly is the spy events, where you create an event spy instance which spies on certain events emitted by the contract. So in our session, we're gonna work with start prank. We're gonna work with start warp, and start prank and start mock call. We're gonna analyze those cheat codes and see how those work. In addition to that, we also have the Forge library function references, where you have certain types of functions or utility functions. We've seen this, the declare function, the deploy function as well. And the print is basically similar. It's a print trait where it displays the data. The nice thing about it, it automatically converts it to a readable format. And then here you have the read text and read JSON, or parse text and parse JSON. So in our case, we're going to use read text, but you can also use read JSON if you like to work with JSON files.
Robert, question from Carlos.
Yes.
Is the mock call for deploy contracts? I guess it's only for deploy contracts.
Yeah, so first you have to deploy the contract. So what we're doing here, the deploy contract. Once you deploy the contract, you receive the contract address, and based on you have to pass for that mock call, you have to pass the contract address for it. Where is it? So you have to pass the contract address and the function name for that certain contract address and the data that you'll mock. So we'll see this in action in a bit. Okay, so let's try to read this from a text file. So to do that, we already imported the necessary things. I'm just gonna comment this out, and we're gonna redefine it again. Let me call data, and then what we can do here is simply, excuse me, call file trait, and then here we have to say new, and then we have to pass the path. So the path, usually the file structure, you'll create a new folder here, gonna call it data, and inside this data, we're gonna say, let's see, something that makes sense, constructor, or call data.text. And then inside this call data, we have to pass the constructor data, which is in our case admin, and then this will automatically be converted to a felt. And here I'm going to say data constructor data.text. And then this should work. And then we won't use this anymore since I've commented that out. And now to see if actually this works, because I have a different definition here, like we have a function here that gives me the admin address. And then here I have a different, like in the call data, I have the admin defined as such. And if you have multiple files or multiple inputs, you can say 10 or things like this, separated by a space, not by commas. But more on this, you can analyze the documentation, and they will say exactly how the file structure should look like. In addition to this, the JSON file is a bit different, where you have to define the A, B, C, D, and they will read it in the order. So A will be first, B will be second, and so on and so forth. Okay, I'll save this for now. And now let's try to build the assertion to check if the constructor successfully built with the admin address. So to do that, I'll have to import the dispatcher again. So to do that, I'll have to import the in this use demo, and then here it's ownable, create dispatcher, and then ownable, create dispatcher trait. That's what we need. Okay, I'll minimize this. Let's go down here. And now what we can do is basically define let dispatcher be equal to ownable create dispatcher. And what we need to pass here is the contract address that we received from deploying our contract. Now we can define let owner, and then I'll retrieve the address. So I can say dispatcher owner, like this. And then I can create an assertion, assert, and then I can call the accounts that we created in the beginning, admin, and then this is equal to the owner that we have there. Otherwise, I'll say not the owner. Okay, let's see. SN Forge. Compiles, and then if it's successfully, then we should have a green light. Okay, it says, oh, okay, yeah, correct. I forgot something here. So we have to actually, once we have that, we have to read the text file. That's why, that's my bad, called data. Actually, no, let me do it like this. So I think called data. So we changed the name to file this one, and then now let call data be equal to each text, and then what we need to send is the actual snapshot of that. And I think this should.
I think there's an issue with the name of the file. It's called call data from .text. No.
Let's see.
Yeah.
Oh, yeah, this owner as well. Yeah. And then Yeah, you're correct. And try to see. Apologize that I skipped from the. Now it works. Thank you. Cool. So what we see here is that our test has successfully passed. So what you just to verify this, you can change this to bad guy, and you'll see that this fails. But because our test is up with the admin, then we'll resume to the admin just to show you. Okay, and then see like it's automatically says not the owner, right? That's the error that we get. So I'll change this to initially to admin. And then one thing that I want to show you here is basically like to make this a bit more helpful with the error commands in a similar fashion as we did with the accounts, we can create a mod and say errors. And this is something that I've seen from Open Zeppelin. They're using this in their Cairo contracts. And the accounts this way, it's from Cairo Practice. If you do not know the project, please check it out. It's they really give you useful tips on Cairo. So with errors, what I can do here is basically create a const and say invalid owner, and then this will be a file 252, and make sure that you stay within the 31 characters, and then caller is not the owner. And now what I can do here is the similar thing as we did with the accounts, and then invalid. What was the? I think it's invalid owner. And then this looks way better. And if you know you change the error or you have to change something, it's very simple rather than changing everything. So errors.
Yeah, you have a typo on your module name.
Sorry.
You have a typo on the module. Yeah, this one.
Correct. Seems like I'm hungry.
Invalid owner. There's a typo in owner.
Oh no. Okay. Let's see now. Apologize for typos. Seems like I'm hungry. So now we managed to build our first test with Foundry. Next up, in a similar fashion, you can also do it for non-admin account, but you can do that if you want to as exercise. Now, next up, let's try to let's try the ownership function. So we try to transfer the ownership from one account to the other, and we have to check that how it works. So to do that, I'll define another test, and I'll call it test transfer ownership. And then now I'll say like, okay, test ownership with admin, because there's two ways we can test it. It's like one, if it's either I'm the admin of the account or I'm the caller. The caller is the admin. Second, we can test it that the caller is not the admin, and that basically we should expect it to fail. So the first, what we build, the first thing is the with the admin. So the transfer ownership is called by an admin account. We can do I mean, you can copy paste this the same. It's pretty much the same thing when you deploy the contract. And what you're gonna do here in addition to this is basically we start to implement the cheat codes. So the first cheat code that we'll implement is the start prank, which allows us to change the address for that contract. So right now we don't have any address set. So to use that, actually first I have to import those things. So use SN Forge, std, and then I think let me just quickly check this. It's okay. So we have start prank and then stop prank. You need stop prank so that you're able to cancel start prank and then just resume to normal. Okay. now that we have that imported, what we can say is, well, we have to change our address to be the admin. So start prank. And then what we need here is, you can analyze the documentation, and you'll see you need a contract address and the caller address that you want to be set to. So the contract address we have here, so we say contract address, and let's say accounts, and then right now I'll want to have it as admin. And we can say dispatcher, transfer ownership, and then the transfer ownership, I believe it takes only, it takes the new owner as contract address. And for this, I think you, like for this case, we can also create like an additional account here or address, and then we say new owner or new admin. Let's say new admin. So we keep the same naming convention and transfer ownership, and I want to transfer the ownership to the new admin. And then finally, I want to do the assertion between this. What we can do is we can call the dispatcher. So we can call the dispatcher directly and then check the owner. Or what you can do is basically you can define this as such, or you can just call that here as well, and then both should work. So I'm not entirely sure what's a good practice. Probably it's a good practice to just define them as such, but this is also a valid way to do it. So accounts, and then new admin, because we set this to the new admin account. And then if not, then I will say that its caller is not the owner, right? That's the error message. So we already defined that error message, and the error message is invalid owner. And would be good. Okay, seems like my it's okay. Okay, it works. Now let's try to compile this. So I'll clear my screen and then SN Forge. Let me know if this is too fast or too slow, or if it's a good pace. So we can see that the transfer ownership worked. And now what you can actually do is try to transfer the ownership without an owner. And basically, you already know that this is going to fail, right? So the function is going to panic. So a really interesting attribute that you can have is something called should panic under the test, and I'll show you that in a second. So next up, I'm going to build.
Question from the chat. Don't we need to use a stop prank at some point?
Yeah, that's true. So in this case, it's not necessary because I'm not continuing the function. But if you want to stop prank, then you can declare stop prank, and that basically this contract won't have the admin as such. So right now, if I try to so let's do that actually. Let's see. Stop prank. So stop prank, and now I can start another prank, and then basically set my new account to, let's say, bad guy, and then I'll try to use the ownership, and then you'll see that it's going to fail. So that's basically it. So it's a good way to have stop prank at the end, but I've also tested it without, and it doesn't really matter. Like once the function finishes, it works as well. But yeah, stop prank, it should be there. Okay. Next up, I mentioned we're going to test the ownership function again, but with a different account. So I'm going to say test, and then FN, I'm going to say the same name, non-admin, bad guy, or bad guy. Should we call it bad guy? Bad guy then. And then we know that this function is going to panic or actually fail. So what you can do is to actually have a valid test is basically you can declare should panic at the beginning. I'm afraid to push tab because I'm not sure what's going to generate. I think this is the old, anyway, should panic. And then usually what the should panic takes is you have, it expects the message that it panics with. So what we're gonna say here is expected, and the panic message is basically the error that we have here at the beginning. Color is not the error. For some reason, I tried to put the constant here, but it's not necessarily working. So yeah, unfortunately, that doesn't work as such. So you have to put the hard code the error message at the top. Now, we're gonna grab everything from here, and the only difference or only change I'm gonna do here is basically set to bad guy address, and then I'll try to change the account. I'll try to transfer the ownership to the bad guy, and then see if this is actually in fact the new owner, right? So again, what I changed here, the start prank, now I'm calling it as a bad guy, and I'm calling it as a bad guy. This automatically should fail because the bad guy is not the admin of the account. And once it fails, we know that this fails or panics, and because it panics, the test will pass because it's a successful test. So let me know if that makes sense. Try to be more clear about it. So we run SN Forge. We'll see that in a second if it's actually working.
You have some S.
Yeah. Seems like I forgot to. I think for the stop rank, you have to also add the contract. Yeah, of course. So whenever you use the stop rank, you have to you have to tell which contract address to stop it for.
You also have some S's, Robert.
Yes.
You have some S's remaining on your, and you have one on the yeah.
That's correct. Now it looks like it works, right? So this test function panics, and it's a successful test because we expected that this function is going to panic because we know that we're calling it as a bad guy, and this indeed works. Now, great. Now the last thing that we can do here is basically try to use the mock date, the mock call, start mock call. And what we can do here is basically use the iData interface, and then we can set the get data function to receive a certain data back. And then we'll see how this actually works in a bit. So first, again, you're gonna decorate with the test attribute, and then we're gonna create a test function with test data, and that with start mock call. Or actually, I should be more get data mock call get data. Okay. And now the same thing, we have to deploy our contract, and then we're gonna get the dispatcher. Something regarding the dispatcher, there's also something called save dispatcher. And the save dispatcher is basically, it gives you back an option. And based on the option, you can create the match function. And depending on what type of errors you have in that certain function, you can create a match on that typical error. And then you can do various things on that. So that's also a very interesting part. So I'll try to use that in here. Use demo. I have to import my iData. This is save dispatcher. And then iData, save dispatcher, create. go back. Now I'll grab the stuff again. I deploy my contract, and then now I'm gonna call this save dispatcher, so it's more descriptive. And then I'm just gonna call I data save dispatcher. Correct. Now, what we need to do here is first for the mock call. If you go to the mock call, first we'll have to set up a data or the return data for that certain function, and then we have to initialize the star mock call. So first, let's define the return data. So let mock return data, and then we're gonna say, let's say a number 100. So that function, whenever I set the mock call for that function, it will always return me the number 100. And I think I'll have to import the start mock. Use SN Forge, SDD, and start mock and call. And okay. And now I can start mock call. And then inside here, there's 3 different variables that it takes. It's the contract address, the function, and the returning data. So I'll go back. We have the contract address already defined. The function is that we want to return is the get data itself. So I'm going to say get data here. And then the mock, the returning data is the one that we defined above. Okay. Now what we can do is we can try to. So I can do is like assert and then call the get data, and then we can do an assert function to see if it's actually working. But first, I'll try to actually change the data. Right? I'll change it to, let's say, to a number 10 or 20, and then I'll try to get the data back. And I'll try to match it with the mock returning data to see that the assertion actually works. So I think for the set data, let me just quickly check. Yeah, so I'll have to change to only owner. That means I need to be an admin. So to be an admin, I have to say start crank. And then I have the contract address. And then here I say account admin. And now I can actually call, I can change the value. So to change the value, I'm going to say dispatcher and then set data. And then set data to, let's say, 20 in that case. And what we can do is actually get the data back. So let data and then save dispatcher. Get data. Oh. And basically, because we have a save dispatcher, it returns an option. So if we want the value, we need to unwrap this to get the value back. Finally, we do an assertion to check if the data that we receive back is equal to, what do you guys think? We should put 20 or mock return data in this case? The question mark. Noted, no question. Okay, so in this case, we put the mock returning data because again, correct. Again, until we have the start mock, until we stop it, it will always return the data that we set. And then here I can define another constant here and say constant invalid data, and then call it start to 52, and then say invalid data. Okay, go back. Errors, invalid data. And again, you know, like I forgot to say, constants should be uppercase, so that's why they're uppercase. Okay, I can stop mock call, contract address, and then finally stop prank, contract address. Let me just quickly check if these two functions, if I have to send anything else. Okay, so I have for the stop mock call, I need the function that has to be stopped. So in my case is get data, and the stop prank, we already seen this as such. Okay, so let's try to run SN Forge and see if this test actually works. Unwrap. Let me just quickly check. Oh, okay. Forgot the actual call. Okay, now it worked, right? So what we can do now, you can also try to see if, okay, what happened? Like what happened here with the set data 20, right? Did it actually set the data or it didn't? In fact, because we haven't done a mock call on that, it's actually our data is set to 20. So once we stop the mock call, what we can do here is again, we can call let data 1, and then we can call again the save dispatcher, get the data, and then unwrap this. And then now we can do the same assertion that we did before, and then say data 1 equal to mock return data, and then if not, then we have errors, invalid data. And then this is just to showcase that this won't be true anymore, right? Why? Because the set data is actually 20 in this case. So once you stop the stop mock call, everything resumes to normal, right? So invalid data. So I'll change this to 20 now, and you'll be able to see that the function actually passes, or the test actually passes. Correct. Okay, so far so good. Any questions?
I don't see any. That's clear.
Nice. That's cool. So if there's no other questions, there are a couple of things in Starknet Forge. Today, we had a new update, it's the 0.7.0. And one of the updates are the implementation of Fuzz testing, and the other one is fork testing. Unfortunately, on the fork testing, I didn't have enough time to set up the project. But with fork testing, you can actually check the documentation. It should be here. And what fork testing does, it allows you to do testing in a forked environment. And basically, you fork the state of a specific real network in that case and perform different actions on top of it, right? So for this, you'll have to define a numerator with the block ID. And then in this block ID, you have the tag, hash, and number. And then once you have that defined and the block tag, you can start performing tests on that certain RPC or the URL that you pass. So in this case, you have the test attribute and you pass the fork attribute where you specify the settings for your environment, right? And then you have the block ID number 123. And then here you perform the certain test for that block ID. And then finally, you have to change, you can also configure SCARP to have these settings. And then I think you can pass these settings like such. Like you don't have to define this anymore here. You just put them in the SCARP, and then you just import the some name, like fork some name, and then you have all of those settings for that fork testing. What I can cover now is the Fuzz testing, and I'm gonna just create another file called test Fuzz, Tyra. And here, I'll just create a simple function so we can see how Fuzz testing works. For our ownable contract, we don't have necessarily like a good implementation of Fuzz testing now, since we don't have, like for example, felt. We can set felts, But a good example is we can create a function that sums up two numbers, for example, and then we can test the assertion for those two numbers. Now the fuzz testing supports only felt to 52, and they're randomly generated. In the future, there will be support for more complex data types. So to perform this test, I'm going to just create a simple sum function, and A should be a felt to 52, and then B should be a felt to 52 again. And then what I'm getting back is basically the sum of those two. And then what I can say A plus B. That's basically the function that I'm going to test. Okay. Now I'm going to just say test here, and then fn test fuzz sum. And for fuzz testing, you have to pass the, the fuzz test takes as input the parameters that will be randomly generated. So in this case, we have, for example, x equals to felt to 52, and then y equals to felt to 52. And then these will be randomly generated. And we need to perform an assertion here. You can call the sum of the function that we created here, and you pass the x and y. And we check that it's equal to x plus y. Otherwise, incorrect sum. This is what we need to define for fuzz testing, the inputs variables that will be randomly generated, and then the assertion itself to see, oh, actually it's here, it's equal, that will be tested, okay? And now what we can do is you can call SN Forge directly, and then basically this will automatically detect the okay. This automatically detects the fuzz test, and then you can see here that so the default for the runs is 256. You're gonna receive 256 runs. And the seed, the fuzzer seed is randomly generated. So whenever you run another test, it will be automatically generated. Usually, whenever you perform tests, it's best to set up a known seed. So whenever you're testing the fuzz testing, it always runs with those randomly generated numbers. And to do this, you can either say in your CLI. So you say fuzzer runs, and you're gonna say 100 runs, and then fuzzer seed, and then let's say the seed number 1, 2, 3, 4, 5, 6. Right? That's those are the input parameters, I think. Fuzzer double Z. And let's see if this works. Okay, you can see that it's 100, and then the fuzzer seed is 1, 2, 3, 4, 5, 6. In the future, it will be added here at the top. So you'll have fuzzer, and then you'll be able to define those settings here. But for now, you can also add these settings in the SCARB. So you have you can define it as tool, SN Forge, and then here you have fuzzer runs, and then 100, and then fuzzer speed 1, 2, 3, 4, 5, 6, whatever. And then we try this SN Forge again. And then we should see those numbers again. Fuzzer seed. The fuzzer seed doesn't work. I'm not entirely sure why. Interesting. I'll have to check this. I just tested this today, so let's see if it's actually fuzzer seed. Okay, I'm not entirely sure why it doesn't pick it up, but this should be the way to do it actually.
I like how minimalistic the setup is, and you only provide arguments to the test function, and that's it. The fuzzer kicks in.
Yeah, it's randomly generated. Like the numbers are randomly generated. You just need to put the seed and the runs, and then it's good to go. And then for now, it's just felt 250 2, but in the future, they're going to support more data types. That's going to be very cool.
Faliat is asking in the chat, how can you test a specific test function instead of the whole test suite with Forge?
That's a good question. So whenever you're doing that, you have the filter. So you can have SN Forge, and then here I think you have the filter, test filter. So what you can do is define the test name. Let's say SN Forge mock call. I think it don't need to have the full name, so you just can pass mock call and should run the mock call. Yes, so you can just give an element of the test, or you can give the whole test as you like. If you have only a test called mock call, you just pass mock call and they should automatically pick it up. And you'll be able to run that particular. Cool. How are we doing on time?
We have like less than 10 minutes.
Do we have time to actually play with Katana?
Go for it. Go for it. If people need to drop before, they're gonna have the recording, so you can come back to recording and watch the rest. So yeah, go for it.
Okay, cool. So just to kind of like show how you can also connect it to Katana, and I think that's really cool. So to do that, I'm gonna use I'm gonna just flip my screen here a bit. I'm gonna first I'm gonna invoke my Katana. So I'm gonna I'm actually wait a second. I have to first define my Starknet account. That's correct. So to do that, let me see, where is it? So I have to go back. And then here we have, what do we have? Starknet Katana. These are my files. And then here we have the Katana account and Katana key. That's what we need. I think we have a N file here. And then these N files, yeah, these are set to Pierre, but I'm going to change to my settings. So to do that, I think I already have, let me just quickly change to my settings. 1 second. Okay. So I have these. So I have my Starknet account, key store, and RPC. I just need to change the path of it. So desktop, and then here. What's the folder name? Basecamp.
Starknet _
Starknet Katana. Okay, and then this should be. Okay, that should work. Let me just quickly change it from here. Basecamp ownable and file. Sometimes I do like the it's way faster. Okay, I think this should be correct, right? So Basecamp, ownable, and Starknet Katana. Okay, let's try to source this. And you already, I think you already did this prior to in the previous session, so this should work. So let me just NPC. Let's see if this works. Okay, cool. Now we're all good and set up. Now, I said I'm gonna start Katana. So disable fees, disable fee actually, and this is where I start my Katana. Oh, apologize. And now I go back to my demo file, And here now I'll try to actually, first I'm gonna try to declare with my preset Starknet Katana account. And then we're gonna try to deploy the contract. And then we'll try to first the call. And also if we want to, we can invoke a function. So to do that, we're gonna call SN Cast. And then if you want to see all the available commands, you can see with SN Cast, and then here you have all the available commands. SN Cast, and then actually go here. And I think the for Starknet accounts, you have everything that you want to deploy. So using a key store and Starknet accounts, you can use these. I'll just pass this link there in the chat so everybody has access to it. And now what I need to do, I can just use this like that. So first I have to define the URL, and then we already preset that to my end file, and then it's called Starknet RPC. Then we have the key store that we already have it as well. Starknet key store. Actually bring this a bit. How can I put? I'll just make this bigger so everybody sees. Next, I need the account itself, and then this is Starknet account. And then the next thing that we have to do is basically call the declare function. And then this declare function takes as parameter the contract name. So contract name. And then our contract name, as I mentioned, is called ownable. And I hit enter. Doesn't work. I did a mistake to my imports, I guess. Let me just Basecamp. Can you actually see the mistake? Because I don't.
Looks nice. Can you just try to make a ls copy pasting the path just to be sure it's existing?
Yeah. I can actually move them to my here, and then
also yes.
Yeah, usually you should have it in the home directory somewhere, place safe, and then you always have access to those. You don't have any issues. So let me just quickly go back. Katana.
Stop.
Yeah, source and then let me try to see if it's actually working.
Werner said that you're missing a slash in the first line.
Yeah.
Perhaps yes. Let's see.
Yeah, it works on.
Oh yeah, that's a good point.
Okay, so now
you need a slash, Robert, as Werner said. You need a slash first for absolute path.
Oh yeah.
Yes,
here
on the account.
Correct.
Nice catch, Werner.
Okay. Okay, now let me go back to my command that I did. Thank you for the help. These typos are always a pain. So SNCast, URL Starknet RPC, key store Starknet key store, and account is Starknet account, and then we have the declared contract name ownable. Fingers crossed. Key store doesn't exist. God damn it. Why is that? Did I put Starknet account Starknet key store? I'm a bit lost, honestly. Export home. Just give me 1 second to actually check this out. I think I forgot that. And now, finally. Finally worked. I think the password is more TPS. No, I'm kidding. I think the password is 1234, if I'm correct, Pierre.
Yes, that's right.
Okay. So apologize for this. It's usually so should have been straightforward, but yeah. Now we've successfully declared our contract. So we have the class hash and the transaction hash, and then you can also see here on the Katana that we have the trace. And we also have some information on that transaction. So I'm going to use this class hash because I needed to deploy my account, SN Cast. And then what I need now is the same thing. Actually, you can call this same thing again and just remove this and then say deploy. And now what I need to do is say the contract address. Or actually, I think it's class hash, because we don't have a contract address, and then we put the class hash. And finally, what we need is basically the constructor data, right? Or the call data. And constructor data. And let me grab the address of it. So for that, I think it's this one. And my address is this, or I could also went in my here and then go to the beginning, which is that one, this one, the first address. Okay, so constructor data, and I'm just gonna pass in my data or my address, the address that we have. So that's the address that we're working with.
Yeah, Okoli said there's a typo in the flag. It's constructor data. There's a typo in constructor.
Correct.
No, still CONST. Wait,
Okay. I think constructor.
Did I misspell as well?
Call data. Call data.
Is it call data?
Yeah.
Oh, yeah. I'm actually, yeah, correct. Deploy. So it's class hash, and then I think it's, yeah, constructor data, call data. Yeah, or you can, you could also use the -v, which is shorter, should be fine. I put the password, and finally we have the address. So we can grab that address. And now what you can do is so basically we successfully deployed this on my DevNet. Okay. And now what I can do is basically, first we can call a function, so SN Cast, and then you can call. The difference between call and invoke is call is just getting the return data, and then the invoke, you actually initiate a transaction for that. So we're gonna say contract address. Hope I don't mess up anymore. Let's see, the contract is the same, that's good. And then a function, and then I'm just gonna say owner to actually see who is the owner of that function. RPC URL is not passed in the, okay, I do have to, I forgot to mention, I do have to pass the RPC as well here. So to pass that function, where is it? I have to change the URL for my Katana. So it could be this one or this one. doesn't matter.
Isn't the RPC a flag for the command?
It could be a flag as well, but here, like if you don't mention it anymore, so then it automatically picks it up. So I can do it like this. RPC it's not found. Okay. Or you could just say URL, as we mentioned before, and then say it's not working. Let me see. Not necessarily doesn't work correctly.
It should be in Forge now, in Tool Forge, the URL.
No, actually, no. Actually, it's correct. It should be SN Cast, not Forge. That's correct.
Yeah,
so you have forgot that. So this is how. So yeah, for Forge you have your own settings, and then for the Cast you do your own settings here as well. So that's how it should work. Yeah, good point. Good point. Thank you. So what we did here. So let me just try to call the function again. Call data, contract address, and function owner. And now it finally works. And now we can see that this is the address that was set initially. And then last that I want to show is actually the invoke function. And then you can SNCast invoke. I mean SNCast invoke, but you also have to pass. For example, if you want to set a certain data, you have to pass the key store again. So to do that, use the URL Starknet RPC and key store again, and then that's key store, and then account Starknet, and then now invoke contract address class. Okay. And then which well, you can say function, and then either we can call the owner. And now it executed the transaction, but the owner actually doesn't do anything, it's just a function. And what you can do is basically, let me just quickly check. We can set the data, and the set data accepts a file to 52. And if I'm correct, you also pass the call data here as well. Contract address, max fee, call data like this. Okay, so to do that, I go back. Function is set data, and then call data, and then for this, we need a file to 52. Yeah, it can be 10, for example. Call data, this call, yeah, typical 1, 2, 3, 4. Okay, now just to, I'm going to use the invoke. Actually, I need to use the call to actually receive function, and then get data, and then let's see if it's actually 10. And then voila, this is 10. It's in hex, and finally we managed to call, set everything that we can on Starknet Cast. So I think that's a wrap up. I think we're over 10 minutes, quite a lot to digest, but I just want to say that in this session, to kind of give a wrap up, during the live coding session, we learned how to create unit tests, basically with Cairo test. Then we learned how to set up a project Foundry test, with Starknet Foundry. And here we implemented the integration test, where we tested different cheat codes, such as the start prank and start mock call. And then lastly, we also checked the fuzzing test, where we performed, we tested a sum function. And then finally, we tried to hook it up all with Katana. where we declared our contract, deployed our contract, and then we called and invoked certain function within our contract. Hopefully this session was insightful, and hopefully you learned something new. And as always, it was really a pleasure to teach this. So thank you very much.
Thank you, Robert. It was great to see Foundry and also the latest function, like just published today, like Forge, and especially the Fuzz. Yeah, so this concludes session 4 testing. Next week, remember, we have front-end, especially how to build, basically how to connect to wallets and interact with the Starknet from your browser. That's it. Thanks to all. I'm just going to stop the recording, and I'll see you all next week. Goodbye.
Thank you.
Thank you. Bye-bye.